Hello everyone, I hope everyone had a great Easter. We did, and we got visited by a bunny in our backyard. It was great. The cats loved it. Cats stayed inside though, so no harm came to a bunny, at least not here. So what we have going on is we're going to look at transforming trig functions. I want to revisit amplitude. Amplitude is huge, and there we go. There's my thing working. I very suspect this pad. So amplitude is basically the distance between the mean line, our equilibrium, from our equilibrium to its peak. Either its peak here or its peak down here. One quick way to do that is this formula right here, high minus low, divided by 2. It's taking the average. So we have 1 minus a negative 1 divided by 2 gives us our equilibrium line, which is y is equal to 0. Well, I'm sorry, I got ahead of myself. We can find it by finding the midpoint between the two as well. So our amplitude is 1, and this is our equilibrium line. This is going to come into play again when we start graphing these puppies. Alrighty, so let's go ahead and talk about transformations. And this is revisiting Algebra 1. Now you've seen me teach this with 1 over b. This is another technique that I sometimes like to use. And it could be the same thing here. So we're going to use this exact same process that you used in your algebra content with our trig. Nothing's changed. The rules are all the same. The language is going to change a bit, especially if you have a physics teacher that's going to do some different things. Because I just use A, B, C, and D, but I could have certainly used H and K. You'll see that in textbooks. You'll see that by other teachers. Just because I teach it this one way, you're going to find 20 different teachers do it different ways, and they're all okay. It's not a big deal. You're going to find physics teachers that'll call this omega, okay, and this phi. Perfectly fine. And of course, this would always be theta right here. So just depends on who you have. So it's the same thing as we had here. This was my vertical input, these two right here, A and K, and this was my horizontal. Same thing here. This right here is my vertical stretch or shrink, but we want to consider this as our amplitude. And that goes back to the previous slide, why it is so very important to understand what amplitude is. And we may have to use some, between the amplitude and the shift up and down, we're going to have to find that equilibrium point as well. This is just one of my 6 trig functions. It could be sine, cosine, cosecant, it could be any of these, but we're going to pretty much stick for our Webex online course. We're going to stick a lot with sine and cosine to keep it very straightforward. It may impact later courses, but you'll catch up. This b here, now remember, we always wanted to get our x lonely. Well, this x, for our purposes, is going to be theta. It's going to be our angle. Typically, we're going to be in radians, but it can be in degrees. We don't have to get this lonely. Can if you want to, and I've done that a lot. It's not a big deal, but we're going to refer to this as our angular frequency as well. This is our horizontal shrink and stretch. This here is my phase shift. Now this phase shift has a formula to it. Basically, it's going to be C over B. Phase shift, I'll call it PS, is equal to C divided by B if it's in this form. If B is lonely, that's just going to be our phase shift. Like for instance, if B was over here, our phase shift would be this right here. You'd actually see it. And this is shifting up and down. All right, so let's take a look at a few examples that I have on that. And these examples can go very quick once you get the rules down. So here comes our first one. We got 3 cosine theta minus pi over 4 plus 2. Again, we're going to be in radians. Unless you see degrees, we're playing in radians. Our amp is super easy. It's this number right there. It's equal to 3. Straight up and it's there. So our amplitude is 3. That means we're going to be 3 above our equilibrium line and 3 below our equilibrium line. Our period, there is a formula for period. And our formula for period is just basically 2 pi over b. Now we're going to learn that one. So what we have here is a 1. My b is equal to 1. So it's just equal to 2 pi over 1, which is 2 pi. So that's my period. Basically, we haven't stretched or compressed our horizontally our parent function of cosine. Phase shift, this is going to be our left or right thing. Now again, that's going to be C over B. Well, this is, my B is 1, right? So it's going to be pi over 4 over 1. And this right here indicates, just like in our thing, that it's going to be right pi over 4. So my graph has got shifted right pi over 4. Our vertical shift is straightforward. We're up 2. Now what would it look like on a graph? I'm going to do a very bad sketch, but I'll do one real quick. So what we have here is that we're shifted up 2. So if we call this my equilibrium line originally y equals 0, we're going to go boop, 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 boop like this, sound effects. And we're going to have y is equal to 2. We shifted up that there. And then we're going to be 3 above. So let me do 3 above right here. 3 above. And we're going to be 3 below right down here. Right, so if this is 2, this is going to be 5. Y is equal to 5. And this is going to be what? Y is equal to negative 1. And we're going to have our parent function shifted to the right pi over 4. So it's going to start over here. Remember, cosine starts high, so it's going to look like this. Oh my goodness. It is terrible to draw with this thing, okay? It's going to look like that, okay? And that's just a horrible sketch, but it's close enough for government work. So let's go ahead and run through the rest of these real quick. So amplitude, this should be about a 1-second answer given these type of problems, 7.5. My B is equal to 1/4. Well, if you want our period, and we're in radians, because I don't see any evidence of any degrees there, it's just 2 pi over B, which is 2 pi over 1 over 4th. Dividing by fractions is as easy as pi. You just flip and multiply. So that's going to be 4 times 2, which is 8, which is equal to 8 pi. All right, that is my period, 8 pi. Yippee-yay. Phase shift. There's nothing going on over here. That's minus 0. So there's no phase shift. And vertical shift, we're down 1. There you got it. All right, next. So here, again, this is a 1-second answer, I hope, in this kind of problem. We can make it more complicated later on. There's a 1 right there. Remember, we're 2 pi over 1. So my period, nothing really happened there. We're shifting right 1 whole pi. Vertical shift, nothing. All right, nice and easy. Next one. And we'll make this one our last one. So this one is in degrees. Big clue there. So remember, our amp, straightforward, 1.8. That means it's 1.8 above our equilibrium and 1.8 below our equilibrium. Our equilibrium is going to be shifted a bit. So our period is normally 2 pi over B, right? But 2 pi corresponds to 360 degrees over B, which is equal to 360 over 10, which is equal to 36 degrees. So our period, this thing is full of energy. It is wiggling back and forth quite a bit. It's in a nice, good little compact. Okay, well, we got a little bit of an amplitude increase, but it's going to be a pretty tight graph. All right, phase shift. So phase shift, I could get the x lonely by dividing, or the theta lonely by dividing by 10 and calling this 10 theta divided by 2. All right, I can have that. But let's just go ahead and do C over B, which is equal to 20 over 10. 10 is equal to 2 degrees. So it's going to be 2 degrees to the right. Vertical shift, up 8. And we are a happy Easter bunny today. Alrighty, so I will get this uploaded. I will see y'all online on Webex tomorrow, and hopefully someone found the golden egg for the Easter hunt, which we couldn't have because we had no one else to play with. So, oh well. Y'all have a good and happy day.